Have you ever looked up at the night sky and felt a sense of awe, wondering just how much is out there that we don't yet understand? The universe is vast beyond comprehension, filled with wonders that defy logic, challenge our understanding of reality, and leave even the most brilliant scientists utterly stunned. From black holes that warp the fabric of space-time to strange cosmic signals with no clear origin, the cosmos is brimming with phenomena that stretch the limits of imagination. It's a place where the unbelievable isn't just possible, it's hiding in plain sight, waiting to be discovered. Today, we're setting off on a journey to explore some of the most extraordinary and bizarre objects ever found in the universe. We'll be counting down the 30 strangest things ever discovered, celestial anomalies, unexplained structures, and cosmic oddities that have left astronomers scratching their heads and rethinking everything we thought we knew. These aren't just distant specks of light. They're mind-bending mysteries that push the boundaries of physics, provoke profound questions about the nature of existence, and remind us just how much remains unknown. So get ready to expand your sense of wonder. We're about to dive into a collection of findings so peculiar, so astonishing, that they almost feel like something from science fiction, except they're real. From stars that shouldn't exist to signals that hint at intelligence beyond our own, this exploration will take you to the very edge of human knowledge and leave you marveling at just how strange, beautiful, and utterly mysterious our universe truly is. And so we begin our countdown with one of the most profound and unsettling mysteries in all of cosmology, an invisible force that has been pulling us towards an unknown destiny for hundreds of millions of years. At number 1 on our list of the strangest things in the universe is the Great Attractor. Imagine the entire Milky Way galaxy, a swirling disk of hundreds of billions of stars, our sun among them, all moving together through the vast emptiness of space. Now imagine that our galaxy, along with every other galaxy in our local supercluster, is not drifting randomly. Instead, we are all being pulled, like leaves in a cosmic river, towards a single point in the void. This is not a gentle nudge. We are racing towards this unseen destination at an astonishing speed of over 600 kilometers per second. The source of this unimaginable gravitational pull is what astronomers call the Great Attractor. For decades, its true nature remained hidden from us, not because it is inherently dark, but because it lies directly behind the heart of our own galaxy. This region of the sky is known as the zone of avoidance. It's an area densely packed with gas, dust, and countless stars from the bulge of the Milky Way, creating a brilliant, opaque wall that blocks our view of the universe beyond in optical wavelengths. It's like trying to see a distant lighthouse through a blinding, thick fog. Our first clues came not from what we could see, but from what we could measure, the peculiar motions of galaxies being drawn inexorably towards this one point. As technology advanced, particularly with space telescopes and instruments that can peer through the cosmic fog using infrared and radio waves, we began to pierce the veil. We discovered that the Great Attractor is not a lone, monolithic object. It appears to be the colossal core of the Laniakea supercluster, a gravitational watershed that our own local group of galaxies is merely a part of. At its heart lies the Norma cluster, a massive congregation of galaxies with a density so great it creates the gravitational anchor for everything around it. Yet, even this incredible discovery may not tell the whole story. The sheer scale of the pull suggests there might be something even larger and more massive behind it. Perhaps an immense concentration of dark matter, the mysterious, invisible substance that makes up most of the universe's mass, or a structure so vast it challenges our very understanding of how matter is distributed in the cosmos. It is a humbling reminder that we are part of a much larger cosmic flow, passengers on a galactic voyage to a destination we are only just beginning to comprehend. But while the Great Attractor represents a mystery of immense scale and gravitational pull, our next entry is a cosmic paradox of form and beauty, a structure so perfectly symmetrical it seems almost too flawless to be real. At number 2 on our list is Hoag's Object, a galaxy that defies conventional classification and challenges our understanding of galactic evolution. In 1950, astronomer Art Hoag was surveying the sky when he stumbled upon a celestial anomaly in the constellation of Serpents. Through his telescope, he saw not a familiar spiral or elliptical blob, but a stunning, almost perfect ring of brilliant blue light. At its center lay a dense, well-defined core of older, yellower stars, and separating the two was a vast, seemingly empty gap of profound darkness. Hoag initially thought he was looking at a planetary nebula, the gossamer shell of gas expelled by a dying star, but he quickly realized the scale was all wrong. This object was far larger and more distant. He had, in fact, discovered an entirely new type of galaxy, one that appeared to be a perfect cosmic bullseye. The statistics of Hoag's object are staggering. The entire galaxy is roughly 120,000 light-years across, making it slightly larger than our own Milky Way. Its core is a compact sphere of aging stars, while the dazzling outer ring is a stellar nursery, brimming with the intense blue light of massive, young, hot stars actively forming. The most baffling part is the gap between them, a void measuring about 75,000 light-years across that is almost completely devoid of any stars or luminous matter, creating a stark and breathtaking contrast. This precise separation is the heart of the mystery. In a typical spiral galaxy, arms of stars and gas would gracefully connect the center to the outer disk. Here, there is nothing but void. How does such a perfectly isolated ring form? The most prominent theory suggests a galactic collision billions of years in the past. The idea is that a smaller galaxy might have shot directly through the heart of a larger disk galaxy. The gravitational shockwave from this incredible encounter would have rippled outward through the larger galaxy's disk, compressing gas and dust in its wake, and triggering a wave of intense star formation in a perfect circular ring, while leaving the central core relatively undisturbed. Another compelling idea points to internal instabilities and resonant phenomena, where the natural orbital rhythms of stars and gas within a galaxy somehow organize themselves into this distinct, separated structure over eons. What makes Hoag's object even more extraordinary is its profound rarity. Despite decades of searching, astronomers have found only a handful of similar ring galaxies, and none display the same degree of perfect, symmetrical isolation. It stands alone as a galactic unicorn, a singular example of a form that theory suggests should be possible, yet nature seems to have created only once with such flawless precision. It serves as a beautiful reminder that the universe is not only a place of violent chaos and immense forces, but also one capable of creating objects of serene, geometric perfection, whose origins remain just out of our reach. Leaving behind the serene, geometric perfection of Hoag's object, we now turn our attention to a mystery not in the distant cosmos, but much closer to home, a story woven from threads of radio signals, space debris, and a deep human desire to believe we are not alone. At number 3 on our list is a legend that has captivated conspiracy theorists and space enthusiasts for decades: the enigmatic Black Knight satellite. The tale begins not with a visual sighting, but with a sound. In the late 1890s, the brilliant inventor Nikola Tesla was conducting experiments with his high-powered radio transmitter in Colorado Springs. He began detecting a strange, repeating signal, a series of rhythmic, mathematical pulses that he could not attribute to any known terrestrial source. He famously speculated in scientific journals that he might be receiving an intelligent communication from another world, perhaps even Mars. Decades later, in the 1920s, amateur radio operators confirmed similar anomalous signals, which they dubbed long-delayed echoes, a phenomenon where their own transmissions seemed to bounce back to them from a mysterious object in space after a delay that suggested an impossibly high orbit. The story truly crystallized in the 1950s. At the dawn of the space race, newspapers reported that the U.S. Air Force had detected a mysterious dark object in a polar orbit around Earth, an orbit that, at the time, was considered impossible for any human-made satellite to achieve. This unknown thing was quickly dubbed the Black Knight by the media. The legend was supercharged a few years later when the Soviet Union launched Sputnik, and a statement from a U.S. naval researcher was misinterpreted. He had simply been tracking a piece of the Sputnik rocket casing, but the public, already on edge, was ready to believe it was the previously reported Black Knight. Then came the imagery. In 1998, during the Space Shuttle Endeavour's STS-88 mission to the International Space Station, astronauts captured a now iconic photograph. It shows a bizarre, angular, and seemingly ancient-looking object silhouetted against the curve of the Earth. For believers, this was the ultimate proof, a visual confirmation of a dark, alien sentinel silently watching over our planet, potentially for millennia. The narrative blossomed into a full-fledged myth, an alien probe of incredible age, perhaps 13,000 years old, orbiting our world and sending signals back to its creators, an artifact so advanced that world governments were desperately trying to hide its existence. The reality, as is often the case, is far more mundane yet no less fascinating from an engineering perspective. The Black Knight is almost certainly a collection of misidentified, ordinary space objects. The famous Endeavour photo, for instance, is not of some distant alien craft. It is a lost thermal blanket. The crew had been installing new modules on the station, and during a spacewalk, a protective thermal blanket broke free and drifted away. The photograph simply captures that piece of lost equipment tumbling slowly end over end in the sunlight, its irregular shape creating a strangely artificial silhouette against the planet below. The anomalous signals picked up by Tesla and others have more prosaic explanations as well. Tesla was likely detecting the natural pulses of a pulsar, a rapidly spinning neutron star that emits regular beams of radiation years before astronomers officially discovered them. The long-delayed echoes were probably caused by complex interactions between radio waves and the Earth's ionosphere. As for the object tracked in the 50s, it was almost certainly a piece of debris from an early, secretive satellite launch or a stray rocket booster, its orbit mischaracterized in the feverish atmosphere of the Cold War. Yet, the legend of the Black Knight persists with undeniable power. It endures because it taps into a fundamental human curiosity. Are we being watched? In a vast and silent universe, the idea that an ancient artifact from another civilization could be circling our world is a profoundly compelling story. It represents a secret history, a hidden truth just beyond the official narrative, and that is a narrative that will always find a willing audience, regardless of the scientific evidence presented against it. It is a modern myth born from the dawn of the space age, a ghost story told not around a campfire, but against the infinite backdrop of the starry sky. Moving from the enduring legend of the Black Knight to a mystery rooted in a single, tantalizing piece of data, we arrive at what many consider the most compelling and frustrating signal ever received from the cosmos. At number 4 is the captivating enigma known as the WOW signal. It was a warm August evening in 1977 at Ohio State University's now defunct Big Ear radio telescope. This massive instrument, essentially a ground-based antenna the size of 3 football fields, was methodically scanning the sky as part of the ongoing search for extraterrestrial intelligence, or SETI. Its operation was largely automated, with a computer printing out reams of data on long sheets of green and white lined paper. Days later, volunteer astronomer Jerry Amon was performing his routine review of these printouts when his eyes landed on a sequence of alphanumeric codes that made him stop dead in his tracks. The values represented the signal's intensity, and one cluster was off the charts. The code 6EQUJ5 was printed, indicating a signal so powerful that it maxed out the telescope's intensity scale. Stunned by the sheer strength and perfect profile of the burst, Amon reached for a red pen, circled the entire sequence, and wrote a single, now legendary word in the margin: "Wow." The signal's characteristics are what make it so profoundly interesting to scientists. It was a strong, narrow-band signal, meaning it was concentrated on one very specific radio frequency. This is significant because natural cosmic objects, like stars or nebulas, emit radio waves across a broad spectrum of frequencies. A narrowband signal, however, is the hallmark of an engineered transmitter, designed to focus its energy for efficient communication, exactly the kind of signature SETI researchers were hoping to find. Even more tantalizing was its frequency, precisely 1,420 megahertz. This is the emission frequency of neutral hydrogen, the most abundant element in the universe. The logic was that any intelligent civilization attempting to signal its presence would logically choose a universal landmark, a frequency any listening astronomer would naturally understand as significant. The signal appeared to originate from the direction of the constellation Sagittarius, near a star group known as Chi Sagittarii. It lasted for a full 72 seconds, the exact duration the Big Ear telescope could focus on any single point in the sky as the Earth rotated. Then it vanished. It was never heard again, despite numerous and dedicated attempts over the decades to find a repeat broadcast using more powerful and sensitive equipment. The silence has been absolute. This one-off nature is the core of the mystery. A single event is incredibly difficult, if not impossible, to verify or study further. This has led to a fascinating divide in theories. On one hand, the possibility of an extraterrestrial origin remains. The signal's perfect parameters align precisely with what theorists predicted an alien broadcast would look like. Could it have been a powerful, one-time beacon from a distant civilization, a cosmic hello that swept past our planet for just over a minute before continuing on its journey into the void? The alternative explanations, while more mundane, are equally intriguing. Some scientists have proposed it was a signal reflected off a piece of space debris in Earth's orbit. Others suggested it might have been a clandestine military transmission that was mistakenly pointed at the stars. A more recent theory, proposed in 2016, pointed the finger at a passing comet. The idea was that large clouds of hydrogen gas surrounding comets could have emitted the signal as they passed through that particular patch of sky. However, this hypothesis was quickly challenged by other astronomers, who noted that comets are not known to emit strong, narrowband radio waves in that frequency, and the specific comets proposed were not even in the telescope's field of view at the time. So, the WOW signal endures, suspended in a state of tantalizing ambiguity. It is not proof, but it is the next best thing, a profound question mark. It stands as a singular data point that perfectly matches our expectations for what contact might sound like, a ghost in the machine of cosmic discovery that continues to inspire the search and remind us that sometimes the most powerful evidence is not a continuous stream of data, but a single, shocking, and unforgettable exclamation written in red ink on a faded piece of paper. And just as we grapple with a signal that came and went in an instant, our next mystery requires us to consider the entire cosmos in motion, revealing a current that seems to flow from a realm beyond our own. At number 5 on our list is one of the most profound and controversial discoveries in modern cosmology, a phenomenon that challenges the very foundation of our understanding of the universe: dark flow. Imagine the universe not as a static expanse, but as a dynamic, flowing entity. The prevailing cosmological model, built upon Einstein's theories and confirmed by countless observations, tells us that on the largest scales, the universe is homogeneous and isotropic. This is known as the cosmological principle. It means the universe should look roughly the same in every direction, and there should be no preferred center or edge to its structure. The primary motion for all galaxies is the expansion of the universe itself, being carried apart by the flow of space-time, like raisins in a rising loaf of bread. But what if we discovered that entire clusters of galaxies, thousands of them, were not just moving with this expansion, but were also being tugged in one specific, coordinated direction? This is precisely what the startling evidence for dark flow suggests. The discovery emerged from a meticulous study of the cosmic microwave background, the ancient afterglow of the Big Bang that fills the entire sky. This faint radiation is not perfectly uniform. It contains tiny temperature variations that act as a cosmic fingerprint, encoding the details of the early universe. As galaxy clusters travel through space, a subtle effect imprints itself on this background radiation due to the hot gas within these clusters. It's called the kinematic Sunyaev-Zeldovich effect. By carefully mapping these minute distortions in the microwave background, a team of astronomers led by Alexander Kashlinsky was able to trace the bulk motion of these enormous structures. What they found was staggering. They detected a consistent, coherent flow of hundreds of galaxy clusters, all moving at velocities exceeding 1 million miles per hour towards a specific region of space between the constellations of Centaurus and Vela. This isn't a local phenomenon. These clusters are spread across billions of light years, and their motion is aligned in a way that defies the gravitational influence of any known matter in the observable universe. According to our best maps of the cosmos, the distribution of both visible and dark matter should not be able to generate such a powerful and coordinated pull on this scale. It's as if these galaxies are all being drawn by a gravitational source so immense it lies beyond the horizon of everything we can see. This is where the mystery becomes truly mind-bending. The most radical hypothesis proposed to explain dark flow is the existence of something outside our observable universe exerting a gravitational pull. One incredible possibility is that we are feeling the tidal influence of another universe, a separate bubble of space-time in a vast multiverse whose mass is tugging on the fabric of our own cosmos. It's a concept that sounds like pure science fiction, yet it emerges from serious theoretical models in physics. Alternatively, the cause could be a colossal, unseen structure made of an exotic form of matter or energy within our own universe, but on a scale so vast we simply haven't mapped it yet. Unsurprisingly, the very existence of dark flow is hotly debated within the scientific community. Some researchers argue that the statistical methods used to detect it are flawed, or that the observed motion is within the margin of error and will disappear with more precise data from newer telescopes. The Planck satellite, which provided our most detailed map of the cosmic microwave background, did not confirm the signal with the same strength, though it didn't entirely rule it out either. The debate continues, a rigorous scientific process to determine if dark flow is a revolutionary glimpse into a multiverse or a monumental statistical illusion. Whether a groundbreaking discovery or an artifact of measurement, the concept of dark flow forces us to confront the humbling possibility that our entire observable universe, with its hundreds of billions of galaxies, might be just a small part of a much grander and stranger cosmic structure. It suggests that the totality of existence may extend far beyond the light that has had time to reach us, and that currents from those unseen shores are already pulling us into the unknown. Leaving behind the enigmatic currents of dark flow, we now turn our gaze inward, toward the very heart of our own galaxy, where a more recent discovery has revealed a colossal and violent chapter in the Milky Way's history. At number 6 on our list are the Fermi bubbles, two immense lobes of searing energy that tower over the galactic core like a ghostly, hourglass-shaped monument to some ancient cataclysm. For years, this vast structure went completely unnoticed, hidden in plain sight, because it doesn't emit visible light. It was only with the launch of the Fermi Gamma Ray Space Telescope in 2008 that astronomers were finally able to see it. By scanning the sky in high-energy gamma rays, Fermi revealed something astonishing: two enormous spheres of intensely hot, radiating gas, each one a perfect counterpart to the other, erupting from the galactic center and stretching far above and below the plane of the Milky Way's spiral disk. The scale is almost impossible to grasp. Each bubble is a titan, roughly 25,000 light-years in diameter. To put that in perspective, our entire solar system is a mere 27,000 light-years from the center. These bubbles are so large that if we could see them with the naked eye, they would dominate a third of our night sky. The energy contained within them is staggering. The gas inside is raging at temperatures of millions of degrees, emitting not just gamma rays, but also X-rays, as later confirmed by other observatories. This isn't a gentle, wispy nebula. It is the aftermath of a truly apocalyptic event, an explosion of unimaginable power that blasted these gargantuan bubbles out into the galactic halo. The central question, of course, is what could possibly have created them. The prime suspect is our galaxy's own supermassive black hole, Sagittarius A star. While it's relatively quiet today, astronomers theorize that several million years ago, it may have undergone a period of ferocious activity as vast amounts of matter, perhaps a huge gas cloud or a stray star, spiraled into the black hole's accretion disk. It wouldn't have all crossed the event horizon. Instead, a significant fraction of that incoming material could have been channeled and focused by powerful magnetic fields into two incredibly energetic jets, shooting outward from the black hole's poles at nearly the speed of light. These jets would have punched through the galactic gas, inflating these massive bubbles and filling them with high-energy radiation. It would have been a brief but spectacular fireworks display on a galactic scale. However, a black hole eruption isn't the only possible culprit. Another compelling theory points to a different kind of starburst, not a single event, but a wave. The galactic center is a densely packed region where star formation can occur in intense, rapid bursts. If a large number of massive stars were born in a relatively short period, they would live fast, die young, and explode as supernova in quick succession. The combined force of hundreds or even thousands of these stellar explosions could have generated a powerful galactic wind, a shockwave of energy powerful enough to blow these massive bubbles out into space. There is even a more exotic, though less likely, hypothesis involving dark matter. The center of the galaxy is thought to be the most dense concentration of this mysterious, invisible substance. Some theories suggest that when dark matter particles collide, they could annihilate each other, releasing a tremendous burst of energy. If such annihilations were occurring at a high enough rate, they could theoretically provide the engine needed to inflate the Fermi bubbles. Despite over a decade of study, no single theory has emerged as the definitive winner. The evidence is still being gathered, with each new observation adding another piece to the puzzle. The Fermi bubbles stand as a lingering echo of a violent event that occurred millions of years ago, a reminder that even our own familiar galaxy has a dramatic and explosive past that we are only just beginning to uncover. They are a testament to the fact that the universe is not a static museum. but a dynamic and often violent arena where even the quietest neighborhoods can hold the scars of incredible ancient upheavals. While the Fermi bubbles revealed a hidden structure of our own galaxy, a new generation of radio telescopes has begun to uncover bizarre formations far beyond it, objects so strange they were entirely unknown to science just a few years ago. At number 7 on our list are the odd radio circles, or enigmatic celestial halos that have astronomers both baffled and utterly fascinated. The story of their discovery begins with the Australian Square Kilometre Array Pathfinder, or ASCAP, one of the most sensitive radio telescopes ever built. In 2019, as astronomers were conducting a massive survey of the sky at radio wavelengths, they began noticing perfect, faint circles of radio emission that simply didn't correspond to any known object. They weren't visible in optical light, or in infrared, or in X-rays. They were ghosts, detectable only by the specific type of energy they emitted. The team appropriately classified them as WTF objects, an acronym for Where's the Flux, but soon gave them the more formal and fitting name of odd radio circles. Their most immediately staggering feature is their sheer scale. These are not small anomalies. A typical ORC can span over 1 million light-years in diameter, making them larger than entire galaxies. If one were close enough to be visible to the naked eye, it would appear larger than a full moon in our sky. Yet, despite their immense size, they are incredibly faint and require the most advanced radio technology to even detect. Most are found far from the crowded plain of the Milky Way, in the so-called quiet regions of the sky, which is likely why they evaded detection for so long. The mystery deepens when we try to figure out what they are. The leading theory suggests they could be the remnant of a colossal explosion, the final shockwave from an event of unimaginable power. One possibility is that they are the spherical blast wave from a merger of two supermassive black holes. When such behemoths finally spiral together and coalesce, they are predicted to release a titanic burst of gravitational waves and energy, which could propagate outward as a perfect sphere, heating intergalactic gas and causing it to glow in radio waves for eons. Alternatively, they could be the result of a starburst event on a galactic scale, where a galaxy undergoes such an intense period of star formation that the combined effect of millions of supernovae creates a spherical tsunami of energy that blows out into the void. But other explanations venture into far more speculative and thrilling territory. Some astrophysicists have proposed that ORCs could be the throats of wormholes. According to some complex theoretical models, a stable, traversable wormhole might be surrounded by a sphere of highly magnetized plasma, which could potentially emit the kind of radio waves we are detecting. While this remains a highly speculative idea, the fact that it is even being seriously discussed in scientific papers highlights just how perplexing these objects truly are. Other, even more exotic, ideas suggest they could be signatures from other universes in a vast multiverse, a concept that pushes the very boundaries of theoretical physics. What makes ORCs so significant is that they don't neatly fit into any pre-existing category. They represent a completely new class of astronomical phenomena, something that was hiding in the universe all along, waiting for our technology to advance enough to reveal it. Their discovery is a powerful reminder that no matter how much we think we know about the cosmos, it is always ready to surprise us with something entirely new and unexpected. They are celestial Rorschach tests. They're simple, circular forms inviting a multitude of interpretations, each one more incredible than the last, and forcing us to reconsider what is possible in the vast and mysterious universe. After peering into the mysterious, empty halos of odd radio circles, our journey now takes us into a different kind of emptiness, not a faint circle on a map, but a terrifyingly vast cosmic desert, a place of almost nothing. At number 8 on our list is a void so immense and so barren, it defies our understanding of how the universe is built. The Boötes Void, often called the Great Nothing. Picture the universe on its grandest scale. For decades, astronomers have mapped the cosmos and found it to be structured like a colossal web, a cosmic network often called the cosmic web. Great filaments of dark matter form the scaffolding, and along these threads, galaxies and galaxy clusters gather like glowing pearls, intersecting at massive nodes. Between these bright strands are the voids, the empty spaces in the web. Most voids are a few tens of millions of light years across, and while they are relatively empty, they still contain a sprinkling of isolated galaxies and small groups. The Boötes Void is something else entirely, discovered by astronomer Robert Kirshner and his team in 1981. It is a spherical region of space, roughly 330 million light years in diameter. To grasp that scale, if you placed our Milky Way at one edge of this void, you would have to travel for 330 million years at the speed of light to reach the other side, and for almost that entire journey, you would see nothing. This is the heart of the mystery. In a region of space that should contain thousands of bright galaxies based on the average density of the universe, the Boötes Void holds only about 60. That is an emptiness of over 99.9%. If you were at the center of this void and looked out, the darkness would be absolute. The nearest galaxies would be so faint and distant that they would be barely visible to the most powerful telescopes, and the night sky would be virtually black, devoid of the stellar islands that fill our own view. It is a place of profound isolation, a true great nothing. Its existence is a direct challenge to the standard model of cosmology, specifically the lambda cold dark matter model, which does a very good job of explaining the large-scale structure of the universe we see. According to this model, voids this large and this empty simply should not exist. The gravitational tug of matter, both visible and dark, should have prevented such an enormous underdensity from forming. It is a statistical outlier of staggering proportions, an anomaly that forces scientists to question if our models are complete or if we are missing a crucial piece of the puzzle. So how did it form? The leading theory is one of merger and growth. Just as galaxy clusters can collide and merge to form larger superclusters, smaller voids can also coalesce. The idea is that several smaller voids, over billions of years, gradually merged together, their boundaries dissolving until they formed one gigantic, spherical emptiness. This process would have gravitationally pushed the galaxies that were once inside out toward the edges, evacuating the center and creating the vast desert we observe today. It's a compelling idea, but even this has trouble accounting for the sheer, staggering emptiness at the void's heart. This has led to more speculative and far more thrilling hypotheses. Some have wondered if the Boötes Void could be the imprint of an encounter with something beyond our universe. In certain multiverse theories, a collision between our universe and another bubble universe could have left a scar, a region where matter was fundamentally scoured away. Others have playfully, though not seriously, suggested it could be the territory of an incredibly advanced Type 3 civilization, one that has harnessed the energy of entire galaxies and somehow moved them, though this is firmly in the realm of science fiction with no supporting evidence. What makes the Boötes Void so deeply compelling is not just its size, but what it represents. It is a monument to randomness and the unexpected structures that can emerge from the chaos of the cosmos. It serves as a humbling reminder that for every rule we think we understand about the universe, there can be an exception so vast it forces us to rethink everything. It is the ultimate empty space, a silent and dark abyss that echoes with questions we are only beginning to learn how to ask. From the profound emptiness of the Boötes Void, we now travel to a place of intricate and startling structure, a cosmic object so geometrically perfect It seems to have been crafted by design rather than celestial chaos. At number 9 on our list is a nebula that stands apart from all others, not for its swirling clouds or billowing curtains of gas, but for its stark architectural beauty, the Red Rectangle Nebula. Located about 2,300 light-years from Earth in the constellation Monoceros, this nebula was first discovered during rocket flights in the 1970s. When ground-based telescopes finally turned toward it, astronomers were astonished. Instead of the soft, ethereal glow of the Orion Nebula or the intricate shells of a planetary nebula like the Ring, they saw something that looked utterly unnatural. Through the eyepiece, it appeared as a near-perfect rectangle of deep red light, bisected by a dark, horizontal bar that gave it the unmistakable appearance of a ladder, with glowing rungs of luminous gas stretching between its sides. The name, while descriptive, is a slight misnomer. More recent observations from the Hubble Space Telescope reveal its true form is that of an hourglass or an X shape, with the central star hidden from direct view. But the initial impression of a geometric marvel remains. The secret to this incredible shape lies in the dynamics of its central star system. At the heart of the red rectangle is not one, but two stars locked in a tight orbit. The primary is a dying star, much like our Sun in its final stages, known as a post-asymptotic giant branch star. It has exhausted the nuclear fuel in its core and is in the process of shedding its outer layers into space. But this ejection isn't happening in a haphazard, spherical manner. The companion star's gravity pulls and confines the expelled gas and dust into two powerful, opposing jets, funneling it into dense disks that orbit the binary pair. We are viewing this intricate system almost directly edge-on. From our vantage point, the thick dust disks obscure the central stars, and the glowing gas above and below them forms the two opposing cones of the X or hourglass shape, with the dark bar being the shadow of the dust disk itself. The latter rungs are thought to be waves of gas, like ripples in a pond, ejected in periodic episodes from the dying star. Beyond its breathtaking form, the red rectangle holds a second, and perhaps even more profound, mystery. Its deep red color doesn't come from the familiar glow of hydrogen, the most common element in the universe. Instead, its spectrum is dominated by an unexplained set of emission bands known as the Unidentified Infrared Bands, or UIBS. For decades, the source of these bands was one of the biggest puzzles in astrochemistry. We now have a compelling answer. They are the signature of complex organic molecules known as polycyclic aromatic hydrocarbons, or PAHs. PAHs are large, stable molecules made up of interconnected rings of carbon and hydrogen atoms, essentially the fundamental building blocks of soot. But their significance is far greater than that. These very molecules are thought to have been abundant in the nebula, from which our own solar system formed. They are incredibly robust and can survive the harsh conditions of interstellar space. Most intriguingly, through a series of chemical reactions, PAHs can form even more complex organic materials, including the probiotic compounds that are the precursors to life. The red rectangle is, in effect, a vast natural chemistry laboratory floating in space. It is demonstrating for us how the raw, inorganic materials ejected by a dying star can be transformed, under the right conditions, into the very ingredients necessary for biology. This makes the nebula a crucial object of study in the field of astrobiology. It provides a direct, observable link between the death of stars and the potential for life elsewhere in the cosmos. The beautiful, crimson geometry we see is not just a celestial sculpture. It is a chemical factory, churning out the complex carbon-based molecules that could one day seed new planetary systems with the potential for life. It is a stunning example of how the universe, in its endless cycles of creation and destruction, weaves together the threads of death, beauty, and the promise of new beginnings. Leaving behind the beautiful chemistry of the red rectangle, we venture to a world where that cosmic carbon has been forged into something unimaginably valuable and utterly hostile. At number 10 on our list is a planet that sounds like it was ripped from the pages of a science fiction novel, a glittering jewel of the cosmos with a heart of unimaginable wealth and fury, the Diamond Planet, known to astronomers as 55 Cancri e. Orbiting a sun-like star 41 light-years away in the constellation Cancer, this exoplanet is a member of a complex 5-planet system, but 55 Cancri e is in a league of its own. It is a super-Earth, a term that belies its truly alien nature. While it is about twice the width of our planet and over 8 times its mass, any similarity to Earth ends there. This world is locked in a terrifyingly close embrace with its host star, completing a full orbit in just 18 hours. To put that in perspective, its year is shorter than a single day on Earth. This proximity creates an environment of pure extremity. The day side of the planet, likely tidally locked to forever face the star, is a blazing hellscape with surface temperatures soaring beyond 2,000 degrees Celsius, hot enough to melt iron and vaporize rock. It is this infernal heat and pressure that are the key to its incredible composition. The planet's density suggests it cannot be made of the same silicon and oxygen-rich rock that forms the Earth. Instead, spectroscopic analysis of its parent star revealed an abnormally high ratio of carbon to oxygen. This crucial clue pointed astronomers toward a stunning conclusion. The entire planetary system, including 55 Cancri e, formed from a protoplanetary disk that was incredibly rich in carbon. Under the immense pressure within the planet's interior, that carbon has likely crystallized into a vast, planetary-sized layer of diamond, potentially hundreds of kilometers thick. The surface itself is thought to be a bleak landscape of graphite, the material in a pencil lead, stretching out towards horizons that literally glitter beneath a blazing sun. The formation story of this world is a tale of cosmic alchemy. In our solar system, the disk of dust and gas that formed the planets was rich in oxygen, leading to the silicate rocks and water oceans we know. But around 55 Cancri, the chemistry was different. Carbon was the dominant element beyond the so-called soot line, the distance from a star where carbon compounds can condense. Here, planets would have accreted from a stew of carbon compounds, graphite, and carbides instead of from silicates. The resulting worlds are known as carbon planets, and 55 Cancri e is our first and best candidate for such an exotic body. It is a world built not on a foundation of rock, but on a bedrock of diamond. The implications of this discovery are profound. It forces us to expand our definition of what a planet can be. Our solar system, with its rocky inner planets and gaseous giants, is just one possible outcome of planetary formation. The universe, it seems, has a far more diverse and bizarre portfolio. The existence of a carbon world like this suggests that elsewhere, under different stellar chemistries, there could be planets made of other exotic materials beyond our current imagination. While the Diamond Planet itself is a scorched, uninhabitable jewel, its discovery opens a window into the incredible variety of worlds that must exist among the stars, each with its own unique and spectacular story written in the elements of its birth. From the glittering, scorched surface of a diamond planet, we now shift our gaze to a cosmic predator of an entirely different scale. At number 11, we encounter a galaxy that doesn't just shine in the void, it consumes it. This is the story of Messier 87, a supergiant elliptical galaxy and a notorious cannibal, whose immense gravity has shaped its history through a relentless diet of smaller galactic neighbors. Residing at the heart of the Virgo cluster, about 53 million light-years away, M87 is a behemoth. It is not a beautiful, swirling pinwheel like our own Milky Way. Instead, it appears as a vast, featureless egg of light, a golden haze containing an almost unimaginable number of stars, well over 1 trillion, compared to our galaxy's mere few hundred billion. Its size is staggering. If placed in our solar system, it would extend well beyond the orbit of Pluto, but its most famous feature, revealed to the world in April 2019, is the supermassive black hole at its very center. The Event Horizon Telescope collaboration gave us the first ever direct image of a black hole's shadow, a fiery ring of light surrounding the darkness of Hawaii, a monster with the mass of 6.5 billion suns. Yet, this incredible black hole is not the cause of the galaxy's cannibalistic nature. It is merely the most dramatic symptom of it. M87's immense gravitational pull, generated by its staggering total mass, is what makes it the dominant force in its local region of the universe. Over billions of years, smaller galaxies that ventured too close have been unable to escape its grasp. They are not swallowed whole in a single, swift event. Instead, the process is a slow, brutal, and beautiful dismantling known as tidal disruption. As a smaller galaxy, perhaps a dwarf spiral, is pulled into M87's gravitational field, immense tidal forces begin to stretch it. The same force that the Moon exerts on Earth's oceans, but on a galactic scale, pulls more strongly on the near side of the victim galaxy than the far side. This differential gravity draws the galaxy out into long, streaming arcs of stars, gas, and dust, which are then drawn into orbit around the predator. These stellar streams, which can persist for billions of years, are the ghostly evidence of past meals, the galactic equivalent of bones scattered around a lion's den. Astronomers using powerful telescopes have identified many such streams surrounding M87, each one a fossilized record of a long-dead galaxy. The final proof of this cosmic consumption lies deep within M87's core. High-resolution observations have revealed that it doesn't possess just one bright, central concentration of stars. It has several. These multiple nuclei are the dense, surviving hearts of galaxies that M87 has consumed. Their own central black holes, though smaller than Hawaii, have spiraled inward through dynamical friction and now orbit the primary beast, eventually destined to merge with it in events that will send powerful gravitational waves rippling through the fabric of spacetime. This process is the ultimate engine behind the growth of the largest black holes in the universe. The story of M87 fundamentally changes our understanding of galaxy evolution. We once imagined galaxies as isolated island universes, forming and evolving on their own. We now know that the largest galaxies in the universe are built through a hierarchy of mergers and acquisitions. They are not born giants. They become giants by eating their neighbors. M87 is a classic example of this violent, bottom-up construction. Its smooth, featureless ellipse is not a sign of a quiet life, but the final result of a tumultuous history of collisions and digestions, which have erased all spiral structure and left behind a placid-looking, yet utterly dominant, gravitational master. It is a celestial testament to the fact that in the universe, the largest structures are often forged by the most destructive acts, while the cannibal galaxy M87 reveals the violent fate of entire star systems. Our next mystery focuses on the light of a single, distant sun, a star whose strange flicker has ignited one of the most passionate and puzzling debates in modern astronomy. At number 12 on our list is a stellar oddity that refuses to be easily explained, a star whose name is now synonymous with cosmic mystery, Tabby's star, officially known as KC 8462852. Located about 1,470 light-years away in the constellation Cygnus, this otherwise ordinary F-type main sequence star, slightly larger and hotter than our Sun, was just one of over 150,000 stars monitored by NASA, a Kepler space telescope. Kepler's mission was to find exoplanets by detecting the telltale periodic dips in a star's brightness that occur when an orbiting planet crosses in front of it. These transits are usually tiny, predictable, and brief, causing a dimming of less than 1%. But Tabby's star was different. When citizen scientists from the Planet Hunters Project, led by Tabetha Boyajian, the star's namesake, began sifting through the data, they found a light curve that defied all convention. The star's dimming events were bizarre in three key ways. First was their depth. Instead of a subtle dip, the star's light would sometimes plummet by a staggering 22%. That's not the signature of a planet. It's the equivalent of something nearly half the size of the star itself moving in front of it. Second was their irregularity. The dips were completely aperiodic, with no discernible pattern. They would happen at random intervals, last for days or even weeks, and vary dramatically in shape and depth. Some were sharp V-shaped declines, while others were gradual, sloping descents into darkness. Third was the long-term trend. Alongside these dramatic, short-term dips, analysis of historical photographic plates revealed that the star's overall brightness had been mysteriously fading for over a century, a slow, enigmatic dimming that added another layer of profound intrigue. The internet, of course, immediately lit up with the most exciting possibility: aliens. The most popular hypothesis proposed that we were witnessing the construction of a Dyson sphere, a hypothetical megastructure envisioned by physicist Freeman Dyson. In this scenario, an advanced Type II civilization would be building a vast swarm of energy, collecting satellites or panels around their star to harness its entire power output. The irregular, massive dimming could be explained by these massive construction projects occasionally blocking our view. It was a perfect science fiction-ready explanation for a seemingly science fiction phenomenon. Astronomers, however, rightly sought more naturalistic causes, though even these have proven to be extraordinarily difficult to confirm. The initial leading theory was a giant swarm of comets. The idea was that a family of exocomets, perhaps disturbed by a nearby star, could have been drawn in towards Tabby's star. As they broke up and vaporized, they would create enormous, irregular clouds of dust and debris that could cause the observed deep, aperiodic dimming. Other theories pointed to circumstellar dust, the remnants of a shattered planet or moon, or even the star itself going through a unique phase of internal activity. Further observations have slowly chipped away at the alien megastructure idea. Detailed spectroscopic analysis revealed that the light blocking the star is not opaque, like a solid structure would be. Instead, the dimming affects blue light more than red light, which is a classic signature of scattering by tiny dust particles. This strongly suggests that whatever is causing the dimming is not a solid, monolithic object, but a misty, heterogeneous cloud of fine material. The most comprehensive study, which analyzed the star's behavior over years, concluded that the dimming is likely caused by a giant, uneven dust cloud orbiting the star, though the origin of that dust remains a complete mystery. And that is why Tabby's star remains one of the greatest unsolved puzzles in astronomy. We have likely ruled out the most fantastical explanation, but we are left with a natural explanation that is almost as baffling. What natural process could create such an immense, dynamic, and evolving cloud of dust that it can block a quarter of a star's light in such an erratic way? The star continues to be monitored by telescopes around the world, and every new dip in its light is met with intense scrutiny. It stands as a powerful testament to the scientific process, a mystery that captured the public's imagination with a thrilling idea, and that continues to drive real, rigorous science in the pursuit of a stranger and ultimately more fascinating truth. After exploring the erratic dimming of Tabby's star, we now turn to a cosmic messenger so elusive it can pass through entire planets as if they weren't even there, a ghostly particle that brings us news from the most violent events in the universe. At number 13 on our list are high-energy neutrinos, the phantoms of the subatomic world, whose detection has opened an entirely new window onto the cosmos. Neutrinos are among the most fundamental and strangest particles in existence. They are nearly massless, carry no electric charge, and interact with ordinary matter so rarely that they are effectively invisible. Every second, trillions of them pass through your body, coming from the sun and other sources, without you ever noticing. They are the ghosts of the particle zoo. But while solar neutrinos are low energy, the ones we're interested in are a different breed altogether. These are high-energy neutrinos, and they are not born in the peaceful nuclear fires of a star. They are created in the most extreme environments imaginable, the particle accelerators of the universe, when protons or other atomic nuclei are accelerated to nearly the speed of light and then smashed into something, either gas or light. The resulting carnage produces a shower of secondary particles, including these high-energy neutrinos. The challenge, of course, is catching them. Because they barely interact, you need a colossal detector to have any hope of snaring one. This is why scientists have built enormous observatories deep underground or under the Antarctic ice. Instruments like the IceCube Neutrino Observatory use a cubic kilometer of pristine Antarctic ice as a detection medium. When a rare high-energy neutrino does happen to interact with an atom in the ice, it creates a faint flash of blue light called Cherenkov radiation. A grid of thousands of sensitive optical sensors buried deep in the ice records this tiny flash, allowing physicists to reconstruct the neutrino's energy and, crucially, the direction from which it came. For decades, these neutrinos seemed to come from all directions with no identifiable sources. They were cosmic mysteries arriving without a return address. That all changed in a watershed moment for astronomy. In September 2017, IceCube detected a single, extremely high-energy neutrino. At almost the same time, telescopes across the globe and in space observed a spectacular event, a dramatic flare of gamma rays from a distant object known as a blazar. A blazar is a supermassive black hole at the center of a galaxy that is pointing a jet of high-energy particles directly at Earth. This particular blazar, designated TXS 0506 plus 056, was over 4 billion light-years away. The alignment in time and direction between the neutrino alert and the gamma-ray flare was too perfect to be a coincidence. For the first time in history, we had pinpointed a definitive source of these cosmic ghost particles. This event marked the dawn of multi-messenger astronomy, a revolutionary way of studying the universe. Instead of relying on just one type of signal, like light, astronomers now combine information from different messengers, electromagnetic radiation, like gamma rays and visible light, gravitational waves, and neutrino. Each messenger tells a different part of the story. The gamma rays from the blazar told us about the incredible energy released in its jet. The neutrino told us something even more profound, that the jet was acting as a powerful natural particle accelerator, smashing protons into photons with such force that it created these elusive particles. The neutrino was a direct witness to the violent particle physics happening near the event horizon of a supermassive black hole. The mysteries they help unravel are fundamental. By tracing these neutrinos back to their sources, which include not only blazars, but also potentially exploding stars, merging neutron stars, or other unknown cosmic engines, we are beginning to solve the century-old puzzle of the origin of cosmic rays. Cosmic rays are high-energy protons and atomic nuclei that constantly bombard Earth, but because they are charged, their paths are bent by magnetic fields throughout the galaxy, making it impossible to trace where they came from. Neutrinos, being neutral, travel in perfectly straight lines from their source. They are the unbiased messengers that can finally lead us back to the cosmic accelerators, that have baffled us for generations. Each one that we detect is a tiny, silent telegram from the edge of a black hole or the heart of a stellar explosion, offering a pure, unaltered glimpse into the most ferocious physics in the universe. While neutrinos offer a direct line to the universe's most violent particle accelerators, our next mystery requires us to look at the oldest light in existence, a fossilized echo of creation itself, and the strange cold shadow some believe was cast by a reality beyond our own. At number 14 on our list is the cosmic microwave background cold spot, a cosmic anomaly that has ignited one of the most profound debates in modern cosmology. To understand the cold spot, we must first travel back in time, almost to the very beginning. The cosmic microwave background, or CMB, is the remnant glow from the Big Bang. It is the oldest light we can see, released when the universe was just 380,000 years old, finally cool enough for atoms to form and for light to travel freely through space. This radiation fills the entire sky, a nearly uniform sea of microwaves corresponding to a temperature just a few degrees above absolute zero, but it's not perfectly smooth. Thanks to satellites like COBE, WMAP, and Planck, we have exquisitely detailed maps of this ancient light, and they reveal tiny, random fluctuations in temperature, hot and cold spots that represent the seeds of all future structure. These are the density variations that would, over billions of years, gravitationally collapse to form galaxies, clusters, and the vast cosmic web. Most of these fluctuations are small and statistically predictable. The cold spot, however, is not, discovered in the data from the WMAP satellite and later confirmed by Planck. It is a vast, circular region in the constellation Eridanus that is significantly colder than its surroundings. Its size is staggering, about 1.8 billion light-years across, and it is colder by about 70 microkelvins. That may sound trivial, but on the smooth canvas of the early universe, it is a massive and profound aberration, a statistical outlier so extreme that it challenges our understanding of the universe's infancy. The immediate and more conventional explanation was that it might not be a feature of the CMB itself, but rather something in the foreground, perhaps a vast, empty region of space, a supervoid, lay between us and the cold spot. The theory of the integrated Sachs-Wolf effect predicts that light traveling through such an immense void would lose a tiny amount of energy as it climbs out of the gravitational well, causing a slight cooling in the CMB signal we observe. It's a cosmic optical illusion. Astronomers went searching for this proposed supervoid, and indeed, they found a large underdense region in the direction of the cold spot. But there's a problem of scale. The void they found, while large, is not nearly large or empty enough to account for the extreme temperature drop we see. The math simply doesn't add up. The observed void might explain only about 10% of the cooling effect. This discrepancy between cause and effect is the heart of the mystery, leaving a gaping hole in the standard cosmological explanation. This failure of the supervoid hypothesis is what has led physicists to propose far more radical ideas. The most mind-bending possibility is that the cold spot is evidence of a collision with another universe. This idea emerges from theories of eternal inflation and the multiverse. In this model, our universe is just one expanding bubble in a frothing, infinite multiverse. Occasionally, these bubbles might collide. If a neighboring universe had bumped into ours in the distant past, the energy released at the boundary of that collision could have left an imprint on our cosmos, a circular scar on the CMB that we now perceive as an anomalously cold region. In this scenario, the cold spot is not a flaw in our universe's map, but a watermark from a reality next door, a cosmic bruise from a run-in with another entire cosmos. Naturally, such an extraordinary claim is met with intense skepticism and rigorous debate within the scientific community. Other theorists have proposed alternative, if equally exotic, explanations originating from within our own universe. Some suggest it could be the imprint of a cosmic texture, a defect in the fabric of space-time left over from a phase transition in the very early universe. Others wonder if our models of the primordial universe itself need tweaking, that the cold spot could be a sign of something unexpected about the inflationary period that spawned our cosmos. The cold spot remains one of the most tantalizing unsolved puzzles in cosmology, precisely because it sits at this intersection of the known and the utterly unknown. It is an anomaly that our standard model struggles to accommodate, a data point that refuses to be easily dismissed, whether it ultimately proves to be a rare statistical fluke, a misunderstood foreground effect, or our first empirical evidence for a multiverse. Its existence forces us to question the completeness of our theories. It is a cold, silent question mark written in the oldest light there is, challenging us to look deeper and wonder if the universe we see is all there is. Shifting our gaze from the vast, cold imprint of the CMB to the dynamic atmosphere of a neighboring world, we find a storm of such perfect geometry it appears almost artificial. At number 15 is one of the most stunning and persistent meteorological marvels in our solar system, the mysterious hexagon on Saturn. Encircling Saturn's North Pole is a cloud pattern so precise it defies belief. This is not a vaguely hexagonal collection of clouds. It is a near-perfect, six-sided jet stream, a towering wall of atmospheric gas that forms a hexagon over 20,000 miles wide, a size so immense that two Earths could be placed side by side within its boundaries. At its center spins a massive, rotating storm, creating a breathtakingly complex and stable system that has captivated astronomers since its discovery by the Voyager missions in the 1980s. What makes it even more astonishing is its longevity. While hurricanes on Earth dissipate after days or weeks, and even Jupiter's Great Red Spot is slowly shrinking, Saturn's hexagon has remained utterly stable, its form unwavering across decades of observation, enduring through the planet's long seasonal cycles. The secret to this incredible shape lies in the fundamental physics of fluids and rotation. Here on Earth, our weather systems are chaotic and turbulent, dominated by swirling circular patterns like cyclones and anticyclones. But in a fast-rotating fluid system, under specific laboratory conditions, scientists can create stable polygonal shapes. The hexagon is essentially a giant, planetary-scale standing wave, a pattern etched into the fast-moving jet stream. As this stream of air races eastward around the planet's pole, it encounters obstacles or variations that create oscillations. On a spinning sphere, these oscillations can become locked into a stable geometric pattern rather than breaking down into chaos. Think of it like the specific note you can sing that causes a wine glass to resonate and vibrate. Saturn's rotation and atmospheric conditions are singing the precise note that causes its atmosphere to resonate in a perfect hexagon. The Cassini spacecraft, which orbited Saturn for over 13 years, provided an unprecedented look into this phenomenon. Its instruments peered through the upper haze layers to measure wind speeds, revealing that the jet stream making up the hexagon's walls screams along at over 200 miles per hour. Cassini also watched as the planet's North Pole emerged from its long winter darkness, using infrared cameras to see the hexagon's structure in the thermal glow of Saturn's internal heat. This confirmed that the pattern is a deep-seated feature, extending hundreds of kilometers down into the atmosphere, and not just a superficial cloud pattern. The central storm itself was shown to be a massive hurricane, with an eye astonishingly 50 times larger than the average hurricane eye on Earth. What truly sets the hexagon apart and makes it such a vital subject of study is what it reveals about planetary atmospheres as a whole. It is a natural laboratory for studying fluid dynamics on a scale we could never replicate. By understanding the precise conditions that generate and maintain this six-sided wonder, scientists can refine their models for how all atmospheres work, including our own. It demonstrates how the interplay between a planet's rotation, its internal heat, and the motion of its atmosphere can produce stunningly orderly structures amidst the chaos. The hexagon is a permanent monument to the hidden laws of physics, a cosmic demonstration that even in the riotous tumult of a gas giant's sky, nature can impose an order of breathtaking and mysterious beauty. Leaving behind the geometric perfection of Saturn's hexagon, we now turn our attention to a visitor from the great dark between the stars, an object that sailed into our solar system and immediately upended everything we thought we knew about celestial wanderers. At number 16 is the story of Oumuamua, the first interstellar object ever detected passing through our cosmic neighborhood, a silent scout from a distant star that remains one of the greatest astronomical puzzles of our time. The discovery was made on October 19, 2017, by the Pan-STARRS-1 telescope in Hawaii, tirelessly scanning the skies for near-Earth objects. It spotted a faint point of light moving at an astonishing speed, one that immediately signaled it was not from around here. Its name, Oumuamua, given by its discoverers, is a Hawaiian term meaning a messenger from afar arriving first, a beautifully apt description. Its trajectory was the first clue to its extraordinary origin. By tracing its path backwards, astronomers confirmed it was not orbiting our sun. It was a traveler on a hyperbolic orbit, meaning it had fallen into our solar system from interstellar space, made a single, sharp turn around the sun, and was now speeding back out into the void, never to return. As telescopes around the world swiveled to observe this historic visitor, the mysteries only deepened. The first shock came when astronomers tried to determine its shape. By measuring how its brightness changed dramatically over a period of hours, they deduced that it was not round. It was incredibly elongated, tumbling end over end through space. The best estimates suggested a shape like a cigar or a pancake, with a length perhaps 10 times its width. This was unlike any asteroid or comet ever seen in our own solar system, where such extreme proportions are unheard of. But the biggest surprise was yet to come. As Oumuamua continued on its outbound journey, precise tracking revealed it was ever so slightly accelerating, deviating from the precise path that would be dictated by the sun's gravity alone. This is a common occurrence for comets, as the sun's heat vaporizes their icy surfaces, creating jets of gas that act like tiny thrusters. But when astronomers pointed their most powerful instruments at Oumuamua, they saw no coma, no fuzzy envelope of gas and dust that is the definitive signature of a comet. It appeared as a completely inert, rocky object, yet something was unmistakably pushing it along. This combination of bizarre traits, its interstellar origin, its strange shape, and its mysterious non-gravitational acceleration ignited a firestorm of scientific debate and public fascination. The most tantalizing, though least likely, hypothesis came from Harvard astronomer Avi Loeb, who suggested we couldn't rule out an artificial origin. He proposed that Oumuamua could be a piece of alien technology, perhaps a light cell, a very thin, reflective sheet designed to be pushed by the radiation pressure from starlight. Its unusual acceleration and lack of outgassing could, in this speculative scenario, be explained if it were an abandoned probe or a piece of a shattered vessel from another civilization. Scientists, however, immediately began searching for more natural explanations, though each one has its own challenges. One theory proposed that Oumuamua was a hydrogen iceberg. In the cold, dense cores of giant molecular clouds, hydrogen could theoretically freeze solid. A chunk of this solid hydrogen, ejected from its system, would slowly sublimate when warmed by the sun, providing the thrust for acceleration while leaving no visible dust trail. The problem is that such an object would be incredibly fragile and would likely have disintegrated long before reaching us. Another, more recent idea suggests it was made of molecular nitrogen ice, similar to the material found on the surface of Pluto. As the sun warmed this nitrogen ice, it would have shed layers of gas, providing the necessary push. This could also explain its unusual shape, as the process of nitrogen ice shedding could have sculpted it into a flattened slab over its long journey. Despite these creative theories, the truth is that we may never know for certain what Oumuamua was. By the time we realized it was there, it was already too far away and too faint for any of our telescopes to gather more detailed data. It has now receded beyond the orbit of Neptune, fading into the darkness from whence it came. Its legacy, however, is permanent. Oumuamua shattered the assumption that our solar system is an isolated island. It proved that interstellar visitors are likely common, and we simply hadn't been looking for them. Its brief passage has fundamentally changed astronomy, leading to new surveys specifically designed to find the next such visitor, so we might be ready to study it in far greater detail. It stands as a profound reminder that the universe is in constant motion, and that sometimes the most revolutionary discoveries arrive unannounced, quietly passing through our backyard on their way to somewhere else, leaving behind only a trail of questions and wonder. If the fleeting visit of Oumuamua represented a mystery that arrived and departed in a flash, our next discovery tells the opposite story, a star that was witnessed dying in a cataclysmic explosion, only to be found later, stubbornly clinging to existence. At number 17 on our list is a stellar phenomenon that defies one of the most fundamental tenets of astronomy, the zombie star, a white dwarf that somehow survived its own supernova. For decades, the textbook definition of a type Ia supernova was one of total, utter annihilation. It was thought to be the final, dramatic end of a white dwarf star. A white dwarf is the incredibly dense, Earth-sized core left behind after a sun-like star exhausts its nuclear fuel. In a binary system, if a white dwarf has a companion star, it can begin to steal material from its partner. As it accretes this gas and dust, its mass increases, creeping toward a critical limit known as the Chandrasekhar limit, about 1.4 times the mass of our Sun. The prevailing theory held that once it reached this limit, the pressure and temperature in its core would become so extreme that it would ignite a runaway nuclear fusion reaction. This detonation would be so violent and so complete that it would unbind the entire star in a matter of seconds, ripping it apart atom from atom and leaving behind no remnant whatsoever. The supernova would shine with the brightness of 5 billion suns, and the white dwarf would be completely obliterated. But the universe, as we are learning, rarely adheres to our textbooks. In 2012, the supernova designated SN 2012Z was discovered in the galaxy NGC 1380. It was immediately identified as a peculiar kind of explosion, a subtype known as a type IX supernova. These events are similar to their type Ia cousins, but are noticeably weaker and slower, as if the explosion is somehow incomplete or fizzling. For years, they were a curious oddity. The true bombshell came several years later when astronomers pointed the Hubble Space Telescope back at the location of the exploded star. They expected to see nothing. Instead, to their absolute astonishment, they found a survivor. The white dwarf that had supposedly just blown itself to smithereens was still there. It had been badly wounded, hurling a tremendous amount of its material into space, but its core had remained intact. It was a stellar zombie, a dead star that had died and yet still persisted. This discovery sent shockwaves through the astrophysics community, forcing a complete re-evaluation of how these cosmic explosions work. The leading theory to explain a zombie star now involves a double detonation. The first detonation might occur not deep within the star's core, but on its surface, as the white dwarf accretes helium from its companion. A layer of this new fuel could build up on its surface. Helium ignites at a lower temperature than the carbon and oxygen that make up the white dwarf. This could trigger a surface explosion that blasts away part of the star's outer layers. This initial blast might then trigger a second, deeper explosion within the core, but one that is weaker and more asymmetric. Instead of a complete unbinding of the entire star, the explosion might only partially disrupt it, like a bomb that goes off with enough force to blow the walls off a building, but leaves the foundation standing. The white dwarf is left as a mangled remnant, its mass now far below the Chandrasekhar limit, while the ejected material from the partial explosion expands outward to create the supernova we observe. The implications of this are profound. First, it means that the cosmic yardstick we have relied upon for decades might need recalibration. Astronomers use Type Ia supernova as standard candles to measure vast distances across the universe because they were thought to always explode with the same peak brightness. The existence of these weaker, failed explosions means we have to be more careful, as there is now a spectrum of possible outcomes, not a single, predictable event. Second, and perhaps more excitingly, zombie stars offer a unique laboratory. A typical supernova leaves behind either a neutron star or a black hole, objects whose interiors are hidden from view forever. A surviving white dwarf, however, gives us a direct look at the heart of the explosion after the fact. By studying its composition, temperature, and the environment around it, we can work backwards to understand the precise physics of the detonation mechanism itself. These stellar survivors challenge our notion of finality in the cosmos. They demonstrate that even in death, there can be degrees of destruction, and that the universe often finds a way to exist in the gray areas between our neatly defined categories. The zombie star is a testament to cosmic resilience, a reminder that some things, even when faced with the most violent forces imaginable, can endure. After confronting the paradox of a star that refused to die, we now journey to the opposite end of the cosmic spectrum, a galaxy that, for all practical purposes, is barely there at all. At number 18, we encounter a celestial ghost, a place where the universe's greatest mystery doesn't just linger in the background, it is the main event. This is the story of the dark galaxy Dragonfly 44, a cosmic paradox that forces us to rewrite the rules of how galaxies are built. Nestled within the Coma Cluster, a dense gathering of galaxies over 300 million light-years away, Dragonfly 44 was discovered not by the light it emitted, but by the light it almost didn't. Using a revolutionary telescope called the Dragonfly Telephoto Array, an instrument designed specifically to detect the faintest, most diffuse structures in the universe, astronomers spotted a vast, fuzzy smudge of light. At first glance, it appeared to be a typical, albeit large, dwarf galaxy, a collection of a few 100 million stars. But when they began to measure its mass, the results were so staggering they defied all logic. By studying the motions of its few, scattered stars, astronomers could weigh the galaxy. The faster those stars move, the more mass must be present to hold them in orbit with its gravity. The measurements revealed a mass comparable to our own Milky Way, a galaxy that contains hundreds of billions of stars. Yet, when they looked at Dragonfly 44, they could only see a paltry 100 million stars, a mere 1% of the stellar content of the Milky Way. The math was inescapable and profound. Over 99.99% of this galaxy's mass had to be made of something that emits no light whatsoever. This galaxy is not just made of dark matter, it is dominated by it in a way we had never before witnessed. It is a dark matter halo that just happens to have a tiny sprinkling of stars caught within its immense gravitational grip. This discovery sent a tremor through the field of astronomy because it directly challenges the leading theory of galaxy formation, known as the lambda cold dark matter model. This model has been spectacularly successful at explaining the large-scale structure of the universe. It posits that the cosmos is built on a scaffolding of dark matter. Clumps of this invisible substance form first, and their immense gravity then draws in ordinary gas and dust, which eventually cools and condenses to form stars and galaxies. In this model, the amount of visible matter in a galaxy should be roughly proportional to the amount of dark matter anchoring it. A massive dark matter halo should host a massive, bright galaxy. Dragonfly 44 shatters that expectation. It possesses the dark matter foundation for a giant spiral galaxy like our own, but it built virtually nothing on top of it. This presents a fundamental mystery. What went wrong? Why did this colossal reservoir of dark matter fail to produce stars? Astronomers have proposed several compelling theories. One suggests that the environment of the dense Coma cluster is to blame. Billions of years ago, Dragonfly 44 might have been a normal, gas-rich galaxy, busy forming stars. But as it plunged into the crowded center of the cluster, it would have encountered the immense pressure of the hot plasma that fills the space between galaxies. This process, known as ram pressure stripping, could have violently torn away its star-forming gas, effectively shutting down its ability to create new stars and leaving behind a dark matter skeleton with only its old, existing stars still shining faintly. Another, more intriguing possibility is that this galaxy never had much gas to begin with. Perhaps the conditions in its particular region of the early universe were just wrong for gas to accumulate, or the gas was too hot to cool down and condense. This would mean that from its very birth, Dragonfly 44 was destined to be a dark giant, a galaxy that was all potential and no product, a cosmic ghost town built around a massive, unseen core. The existence of Dragonfly 44 and other galaxies like it, known as ultra-diffuse galaxies, forces a profound shift in our perspective. We can no longer assume that a faint, wispy galaxy is necessarily a lightweight. It could be a titan in disguise, a hidden king whose power is invisible to our eyes. This discovery suggests that the universe might be teeming with these dark giants, lurking unseen in the voids between the bright pinwheels we normally observe. They represent a hidden population, a dark side of galactic evolution that we are only just beginning to uncover. Dragonfly 44 is a stark and humbling reminder that what we see with our telescopes is only the glittering tip of a much deeper, darker cosmic iceberg. If the ghostly galaxy Dragonfly 44 represents a place where the universe's mysteries are written in absence, our next discovery showcases a phenomenon of such intense, violent presence that it warps the very fabric of reality around it. At number 19, we enter the realm of the most powerful magnets in the known universe, celestial monsters, where physics is pushed to its absolute breaking point, the magnetar. To understand the sheer, staggering force of a magnetar, we must first start with its origins in one of the most cataclysmic events possible, a supernova. When a massive star, many times heavier than our Sun, reaches the end of its life, its core collapses under its own immense gravity. For most neutron stars, the ultra-dense, city-sized remnants left behind, this collapse spins them up to incredible speeds and grants them a powerful magnetic field. But for a rare few, about 1 in 10, the conditions are just right for something far more extreme. During the chaotic seconds of the core's collapse, the convective currents of superheated, magnetized plasma act like a cosmic dynamo, amplifying the nascent magnetic field to an almost incomprehensible degree. The result is a magnetar, a neutron star born with a magnetic field so strong it defies all earthly analogy. The numbers alone are enough to short-circuit your intuition. A typical magnetar's magnetic field is measured in the range of 100 trillion to a quadrillion Gauss. The Earth's protective magnetic field, which guides compasses and shields us from solar radiation, is a mere half a Gauss. A common refrigerator magnet is about 100 Gauss. A magnetar's field is so powerful that it would be instantly lethal from a distance of over 600 miles away. At that range, the magnetic field would be strong enough to literally rip you apart on a molecular level, pulling the iron from your blood and distorting the very atoms that make up your body. It is a force of pure physics that operates on a scale we can calculate but scarcely imagine. This unimaginable power doesn't just sit idle. It manifests in events of apocalyptic violence, known as starquakes and giant flares. A neutron star's crust is a lattice of iron nuclei, a structure harder than diamond, but even this super-dense crust is no match for the titanic forces of a magnetar's evolving magnetic field. As the field twists and strains, it can fracture the star's surface, causing a starquake. This is the stellar equivalent of an earthquake, but the energy released is beyond comparison. A single crack in the crust, a shift of mere centimeters, can release more energy than our sun will emit in 100,000 years. On rare occasions, this energy is channeled into a giant flare, the single most violent transient event known to occur in the present-day universe. In a fraction of a second, a magnetar can unleash a blast of gamma rays and X-rays that outshines every star in our entire Milky Way galaxy combined. We have witnessed these events from across the galaxy. In 2004, a blast of radiation from a magnetar 50,000 light-years away, named SGR 1800-620, actually compressed Earth's ionosphere and briefly distorted our planet's magnetic field. If this event had occurred within 10 light-years of Earth, it would have likely triggered a mass extinction, stripping away our ozone layer and bathing the planet in lethal radiation. A closer one, say within a few light-years, could sterilize the planet entirely. Thankfully, the nearest known magnetar is much farther away. The existence of magnetars forces us to confront the most extreme limits of matter and energy. There are natural laboratories for states of physics we could never hope to recreate on Earth, where magnetic fields are so strong they can bend light and create a vacuum that spontaneously spawns matter and antimatter particles. They are the universe's ultimate powerhouses, a demonstration that even after the spectacular death of a star in a supernova, the aftermath can be more violently creative than the explosion itself. They are not just dead stars, they are cosmic vampires, feeding on their own incredible internal energies to unleash storms of radiation across the galaxy, reminding us that the cosmos is home to forces that are both terrifyingly destructive and awesomely beautiful. From the crushing magnetic fury of a magnetar, we now turn to a phenomenon of immense subtlety and cosmic precision, a demonstration of how the universe can bend the very fabric of reality to create one of its most perfect and useful illusions. At number 20 is a structure so geometrically exquisite it seems almost divine, the Einstein Cross, a celestial alignment that acts as a natural telescope and a fundamental test of our understanding of gravity itself. Gravity, as described by Einstein's general theory of relativity, is not a force in the traditional sense, but a curvature of space-time caused by mass. Imagine the universe as a vast, taut rubber sheet. Place a heavy bowling ball on it, and it creates a deep well. Now, roll a marble past the bowling ball. Its path will bend as it travels through the curved space around the heavier object. Light, though massless, behaves in exactly the same way. Its path is bent by gravity. When a massive object, like a galaxy, lies directly between a distant light source and an observer, this effect can become spectacularly dramatic. The galaxy's immense gravity acts as a lens, warping the space around it and distorting the light from the object behind it. This is gravitational lensing, and the Einstein cross is one of its most perfect and beautiful manifestations. Discovered in 1985, the Einstein cross, officially known as Q2237+030 or QSO2237+0305, is located in the constellation Pegasus. At first glance, through a powerful telescope, it appears as a perfect cross of 4 blue points of light surrounding a fainter, golden-hued central smudge. The reality is even more incredible. The 4 blue points are not 4 distinct objects. They are 4 separate images of the exact same thing. They are all light from a single, incredibly distant quasar, a phenomenally bright active galactic nucleus over 8 billion light-years away. The fainter central object is the lens itself, a galaxy a mere 400 million light-years from us, whose gravity has fractured the quasar's light and smeared it into this iconic cross-shaped pattern. The significance of this cosmic mirage extends far beyond its breathtaking beauty. For astronomers, it is a gift, a natural telescope of unprecedented power. The lensing effect doesn't just split the image, it magnifies it. The foreground galaxy acts as a colossal magnifying glass, amplifying the light from the distant quasar, allowing us to study it in far greater detail than would ever be possible without this natural assist. Through the Einstein cross, we can probe the structure of the quasar's accretion disk, measure the winds blowing from its central black hole, and observe changes in its brightness that are otherwise too faint to detect. It provides a unique window into the early universe, letting us examine an object from a time when the cosmos was less than half its current age. Furthermore, the precise configuration of the cross serves as a rigorous laboratory for testing the very laws of physics. By meticulously measuring the time delay between the flickering of the 4 individual images, since the light for each takes a slightly different path around the lens, galaxy scientists can calculate the Hubble constant, the rate of the universe's expansion, with remarkable precision. Any deviation in the predicted arrival times of these light signals can also test the intricacies of general relativity itself. Perhaps most importantly, the way the lens distorts the background light reveals the distribution of mass within the foreground galaxy, including its halo of invisible dark matter. By mapping this invisible scaffolding, the Einstein cross provides some of the most compelling indirect evidence for dark matter and helps us understand how this mysterious substance is structured throughout the cosmos. The existence of such a perfect alignment is incredibly rare, requiring the distant quasar, the lens galaxy, and our own planet to be in an almost perfect straight line. That we have found it at all is a testament to the vastness of the universe and the power of our telescopes. The Einstein cross is more than just a celestial curiosity. It is a fundamental tool. It is a confirmation of a 100-year-old theory, a probe for the invisible components of the universe, and a magnifying glass held up to the distant past. It stands as a perfect example of how the cosmos can create order from chaos, using its own fundamental forces to reveal its deepest secrets in the most unexpected and beautiful ways. Leaving behind the perfect cosmic lens of the Einstein cross, we now turn to a celestial object that is not a lens but a snapshot, a fleeting moment of cosmic violence frozen in time and glowing with an eerie, beautiful light. At number 21 on our list is a nebula so unique and so recently understood that it represents an entirely new chapter in our understanding of stellar life cycles, the mysterious Blue Ring Nebula. For 16 years, this object was an enigma hiding in plain sight, discovered in 2004 by NASA Galaxy Space Telescope, which surveyed the universe in ultraviolet light. It appeared as a simple, faint blue ring. It was cataloged and largely set aside, a curious anomaly without a clear explanation, The mystery wasn't just its color, it was its structure. Most planetary nebulae are intricate, bipolar clouds of gas, often resembling butterflies or hourglasses. This was different. It was a nearly perfect ring, and further analysis revealed something even stranger. It wasn't just one ring, but two, expanding in opposite directions like a pair of vast, invisible smoke rings. At its heart sat a star, known as 2D259731, which seemed to be the source of the phenomenon. The puzzle was complete: a central star, a double ring structure visible only in ultraviolet light, and no clear theory to tie them all together. It took over a decade of relentless investigation, using some of the world's most powerful telescopes to finally piece together the incredible story. The Blue Ring Nebula, it turns out, is not the gentle death of a single star. It is the spectacular aftermath of a stellar merger, a cosmic crime scene where two stars became one. The evidence points to a dramatic and violent event that occurred relatively recently. In cosmic terms, a mere few thousand years ago, astronomers believed the system was once a binary pair, two stars locked in a close gravitational dance. The more massive of the two stars exhausted its hydrogen fuel first and began to swell into a red giant. As it expanded, it encroached on the space of its companion, transferring mass and spiraling ever closer. Eventually, the smaller star plunged directly into the bloated atmosphere of its giant partner. This was not a head-on collision, but a slow, catastrophic consumption. For a brief period, the smaller star orbited inside the larger one, its motion creating immense friction and turbulence that ejected the giant star's outer layers into space. This ejected material was flung out in two opposite jets, perpendicular to the orbital plane of the doomed binary system. As the smaller star's orbit decayed, it finally merged completely with the giant's core. The tremendous energy released from this final merger then blasted through the poles of the ejected gas, inflating it into two vast, expanding cones. From our vantage point on Earth, we are looking directly down the barrel of one of these cones. The near-perfect circular ring we see is actually the base of that cone, a thick rim of glowing gas surrounding a central cavity. The far cone, pointing away from us, is invisible, creating the illusion of a single, isolated ring. The eerie blue glow that gives the nebula its name is the final, crucial clue. That specific shade of ultraviolet blue is not emitted by the hot gas itself. Instead, it comes from an incredibly energetic process. The shock wave from the stellar merger is racing outward at tremendous speed, slamming into a pre-existing shell of dust and gas that was likely ejected by the star during its earlier red giant phase. This colossal impact excites the hydrogen molecules in the dust shell, causing them to fluoresce and radiate that specific wavelength of blue light. It is a temporary phenomenon, a flash in the pan that will fade as the shockwave dissipates and the gas cools. We are witnessing a cosmic event that lasts for only a tiny sliver of cosmic time, a brief phase in the aftermath of a stellar merger that had never been directly observed before. This discovery is monumental because it provides a missing link. Astronomers have long theorized that stellar mergers happen, and they have even observed the end results: stars with unusual chemical compositions or rapid rotation that suggest a violent past. But they had never caught one in this specific, short-lived phase where the ejected material is still being lit up by the merger's shockwave. The Blue Ring Nebula is that rare snapshot. It is the equivalent of finding the freshly cooled crater of a volcano we only knew from ancient geologic layers. By studying it, we can test our models of binary star interactions and understand the precise mechanics of how these mergers unfold, how much mass is ejected, and what kind of remnant star is left behind. It transforms a theoretical possibility into an observed fact, proving that the universe can forge new stellar identities through violent, transformative collisions, and leaving behind a beautiful azure halo as the only sign of its celestial alchemy. And just as the Blue Ring Nebula unveiled the aftermath of a violent stellar partnership, another recent discovery has revealed a far more subtle but equally profound cosmic relationship, one that involves a gravitational trap so small it was once thought impossible. At number 22, we have the smallest black hole ever identified, a celestial lightweight with a colossal name, the Unicorn, located a mere 1,500 light-years away in the constellation Monoceros, which fittingly means the unicorn. This object was discovered not by what it emitted, but by the profound influence it exerted on its companion. That companion is a red giant star, a star that should have a predictable, rhythmic pulse as it ages, but astronomers led by Thurundu J. Essing at Ohio State University noticed something peculiar in the data. The light from this red giant was periodically dimming and brightening in a way that suggested it was being stretched and squeezed, as if by an invisible partner's gravity. This distortion, known as tidal distortion, is a telltale sign that the star is not alone. It is locked in a tight 3-month orbital dance with an unseen object. The key to the mystery lay in calculating the mass of this invisible companion. Based on the red giant's wobbling motion, the unseen object had to have a mass of just about 3 times that of our Sun. This number is profoundly significant in astrophysics. It sits directly in what is known as the mass gap. For decades, astronomers have observed that the densest neutron stars, the crushed cores left behind by supernova, top out at around 2.1 solar masses. Conversely, the smallest known black holes, formed from the collapse of the most massive stars, started at around 5 solar masses. Between 2.1 and 5 solar masses was a puzzling desert, an empty zone where no objects had ever been conclusively found. Theorists debated what, if anything, could exist there. The Unicorn, with its 3 solar masses, lands squarely in the middle of this gap, strongly suggesting it is a black hole. This discovery challenges long-held assumptions about stellar evolution. How does a star collapse to form such a petite black hole? It's possible that the progenitor star was unusually low in metals, the elements heavier than hydrogen and helium. Such a star might lose less mass through stellar winds during its life, allowing its core to remain just heavy enough to collapse into a black hole, but not so heavy that it forms a larger one. Alternatively, the Unicorn could be the product of a merger, much like the event that created the Blue Ring Nebula, where 2 neutron stars or other dense objects combined to form a single object whose mass falls into this forbidden range. Finding the Unicorn suggests that there may be a vast, hidden population of these low-mass black holes throughout our galaxy, previously invisible to us because they don't actively feed on matter and emit the telltale X-rays we typically use to find them. They are the cosmic ghosts, silently orbiting companion stars, their presence betrayed only by the subtle tidal pull they exert. The Unicorn is more than just a record holder. It is a key that unlocks a new understanding of the final fates of stars, proving that the universe is always ready to fill the gaps in our knowledge with something truly magical. If you thought the environment around a supermassive black hole was strange, the reality is even weirder. At number 23, we venture into the chaotic heart of our own galaxy to meet a class of objects so bizarre they defy simple classification: celestial chameleons that blur the line between star and gas cloud. These are the G objects, and they are doing things around Sagittarius, a star that nobody thought were possible. For years, astronomers observing the galactic center noticed a few faint, dusty blobs orbiting perilously close to the black hole. Initially, they were cataloged as simple gas clouds, perhaps the remnants of stars torn apart by tidal forces. But as researchers tracked their movements over decades, it became clear these were no ordinary clouds. The first major clue came with G1, an object that made its closest approach to the black hole around 2001. Instead of being completely ripped apart and devoured, as a fragile gas cloud would be, it did something astonishing. It stretched out, elongating dramatically as it swung around the black hole, but then, as it moved away on its long, elliptical orbit, it somehow managed to contract back into a compact object. This was not the behavior of a simple cloud of gas, which would have been irreversibly shredded and scattered. It was acting like something with a coherent structure, something that could hold itself together. The mystery deepened with the discovery of more of these entities, now named G2, G3, and so on. The most intensely studied has been G2. In 2014, it made its own death-defying plunge toward Sagittarius, a star. The world's most powerful telescopes, including the Keck Observatory in Hawaii, were watching. The prevailing theory was that this was a cloud of hydrogen gas, and its inevitable destruction would create a spectacular fireworks show as the black hole fed, finally revealing its secret. But yet again, the G object defied expectations. It was stretched into a long, spaghetti-like strand by the black hole's immense gravity, just as predicted. But then, it emerged from its closest approach, apparently intact. It didn't trigger a major feeding frenzy. It simply regrouped and continued on its orbit, much to the astonishment of the astronomers. This incredible resilience pointed to a startling conclusion. These G objects must have a dense, stellar core hidden inside their dusty cocoons. So what are they? The leading theory is that we are witnessing the final act of a stellar merger. In the densely packed environment of the galactic center, stars can be gravitationally nudged into binary pairs. Over time, their orbits can decay, forcing them to spiral inward and eventually collide. The G objects could be the product of such a violent union of two stars that smashed together and merged into a single, larger star. This merger would have been incredibly energetic, blowing off a vast envelope of gas and dust that now enshrouds the newly formed, bloated star. This explains the dual nature perfectly. The outer shroud of gas and dust gives the object the appearance of a cloud, while the dense, merged star at its heart provides the gravitational anchor that allows it to survive its terrifying encounters with the black hole. It's a star wearing a giant, puffy coat, and even the most extreme gravitational forces can only tug at the coat, not destroy the star within. However, some scientists propose even more exotic possibilities. Could they be something entirely new, a form of star we haven't encountered before, one that naturally swells to an enormous size in its old age, puffing out vast amounts of material? Or perhaps they are immense star-forming clouds that are paradoxically stable enough to withstand the black hole's pull. Each new observation adds a piece to the puzzle. Beyond their identity crisis, the G objects are invaluable scientific tools. Their orbits serve as exquisite probes of the gravitational field immediately around Sagittarius, a star. By meticulously tracking their paths, astronomers can test Einstein's theory of general relativity in one of the most extreme environments in the galaxy, searching for any subtle deviations from its predictions. Furthermore, as these objects swing close to the black hole, their outer atmospheres are stripped away, getting sucked into the accretion disk. This process provides a slow, steady trickle of food for the otherwise quiet black hole, allowing us to study how these cosmic monsters feed on small, subtle meals rather than large, dramatic ones. They are teaching us that the neighborhood around a supermassive black hole is not just a place of destructive chaos, but also a dynamic ecosystem where strange, hybrid objects can thrive, dance with the monster, and live to tell the tale. From the churning chaos of the galactic center, we now turn our search inward, back to our own solar system, where a different kind of gravitational mystery is unfolding in the frozen darkness beyond Neptune. At number 24, we explore a modern-day astronomical detective story, a hypothesis that has reignited the thrill of planetary discovery, the search for the elusive and theoretical Planet 9. The story begins not with a direct observation, but with a pattern of orbits that simply shouldn't exist. In the cold, dark realm of the Kuiper Belt, far beyond the orbit of Neptune, there exists a population of small, icy worlds known as trans-Neptunian objects, or TNOS. Most of these objects have orbits that are randomly oriented, a scattered disk of debris left over from the solar system's formation. But in 2016, astronomers Konstantin Batygin and Mike Brown at Caltech made a startling announcement. They had identified a small group of these distant objects specifically, those with the most elongated orbits that take them hundreds of astronomical units from the Sun, whose paths were not random at all. Their orbits were clustered. Not only were there points of closest approach to the Sun, their perihelia, grouped together in space, but their orbits were also tilted in the same direction, all swooping down below the plane of the solar system at a similar angle. The probability of this happening purely by chance is astronomically low, less than 0.0002%. It was as if the invisible hand of a shepherd was guiding them, keeping their paths aligned. The most elegant explanation for this strange orbital clustering is the gravitational influence of a massive, undiscovered planet. According to the mathematical models, this world would be a true giant, a super-Earth, or a mini-Neptune with a mass 5 to 10 times that of our own planet. Its orbit would be immense, taking it on a long, elliptical journey around the Sun that lasts between 10 and 20,000 years. At its closest, it might come within 200 or 300 astronomical units of the Sun, but at its most distant, it could be as far as 600 to 1,200 AU away, placing it deep in the scattered disk, in a region of space we have barely begun to map. Its gravitational pull would act as a kind of orbital resonance, herding the orbits of these smaller TNOS into the peculiar clustered configuration we observe, while simultaneously clearing its own path of other objects over billions of years. The search for this phantom world is one of the great astronomical quests of our time. Teams are using the world's most powerful wide-field telescopes, like the Subaru telescope in Hawaii, to meticulously scan the vast proposed search area, looking for a single, faint point of light moving slowly against the backdrop of fixed stars. It is a needle in a haystack endeavor of epic proportions. Because the planet's orbit is only roughly constrained, astronomers must cover an enormous swath of sky. And because it is so distant, it would be incredibly faint, reflecting only the tiniest amount of sunlight. Each potential candidate must be tracked over multiple nights to confirm its motion, a painstaking process that has so far turned up empty-handed, yet the search continues. Naturally, a hypothesis this grand faces significant scrutiny and has spurred the development of compelling alternative explanations. Some scientists propose that the gravitational anomalies could be explained not by one large planet, but by the collective pull of many smaller objects, a massive, unseen disk of icy debris that we haven't detected yet. Others have ventured into more exotic territory, suggesting that the peculiar orbits could be the result of a primordial black hole, a leftover from the Big Bang with the mass of a planet, captured by our solar system eons ago. There is even a chance, though a small one, that the clustering is a statistical fluke, an illusion created by observational biases, where we have only found the TNOS that happen to be grouped together and have missed the many others that are not. Whether Planet 9 is ultimately found or not, its hypothesis has already proven its immense value. It has forced us to re-examine the outer solar system with fresh eyes and renewed vigor. It has reminded us that our inventory of planets might not be complete, that a world larger than Earth could still be lurking in the perpetual twilight, at the edge of our own cosmic backyard. Its presence felt only through the subtle gravitational tugs it exerts on its tiny, icy neighbors. It represents the enduring power of prediction in science, a mathematical ghost that challenges us to look deeper, to search wider, and to remain open to the possibility that the greatest discoveries are often those we have not yet seen, but can already sense shaping the world around us. And so, our journey through the cosmos comes to a close, having taken us from the incomprehensible gravitational pull of the great attractor to the mathematical ghost of Planet 9, at the very edge of our own solar system. We have stood in awe of perfect geometries like Saturn's hexagon and Hoag's object, witnessed the lingering fury of magnetars and zombie stars, and puzzled over enigmatic signals and visitors from the depths of interstellar space. Each of these 30 discoveries, from the vast emptiness of the Boötes void to the strange resilience of the G objects dancing with a black hole, serves as a profound reminder that the universe is not a static museum exhibit. It is a dynamic, chaotic, and breathtakingly creative arena, constantly challenging the limits of our understanding and defying our most confident predictions. These are not just curiosities, they are the very engines of scientific progress. Every anomaly, every unexplained signal, every statistical outlier is a question written in the fabric of reality, pushing researchers to develop new technologies, conceive new theories, and see the cosmos with fresh eyes. The mystery of the WOW signal drives the continual refinement of SETI. The bizarre behavior of Tabby's star forces us to reconsider the life cycles of solar systems. The theoretical need for Planet 9 sends our most powerful telescopes on a grand hunt, mapping the outer darkness with unprecedented detail. It is in these moments of not knowing that the greatest discoveries are born, reminding us that the goal of science is not to have all the answers, but to have better questions. Ultimately, this tour of the strange and wonderful is a celebration of human curiosity itself. It is that innate desire to look up, to question, and to explore that has brought us from ancient stargazers to a species that can map the afterglow of creation and weigh invisible galaxies. The universe's endless capacity for wonder is matched only by our own capacity to be wonder-struck. So we want to hear from you. Which of these strange finds captivated your imagination the most? Was it the diamond planet, the cosmic horror of a magnetar, or the tantalizing possibility of a multiverse hinted at by the CMB cold spot? Let us know in the comments below, and share what you think might be the next great cosmic mystery waiting to be solved. If this journey to the edge of understanding sparked your curiosity, be sure to subscribe and hit the notification bell so you don't miss our next exploration into the mysteries of space, technology, and the far reaches of physics. Thank you for joining us on this incredible voyage. Never stop asking questions, never stop seeking answers, and always remember to look up at the stars with a sense of wonder. The universe is vast, strange, and full of secrets waiting just for you.